Some of the enclosures will carry multiple ratings. Type steel enclosures would usually be 3R or 4. If you wanted a 4X steel, you're going to go to a stainless steel. And it just deals with what type of environment it's going to be in. You see 3R is rain tight. It's protected from rain falling down. So you couldn't spray a hose at a 3R panel because there's a possibility water could go up and get into something. Type 1 is just basically protection from you can't stick your fingers in the live components when the door is closed. So. I believe that's the end of the slides we've got. That's all cool and stuff there. So if you'd like to, we've brought some panels. If you'd like to come up and take a look and see the different panels we have up here. I think Ross brought in yeah, this is just basically a simplex little economy panel that we build. This is an economy time dose panel. Anybody wants to come look at that? We've got various different devices up here, float switches and transducers. Does anybody deal a lot of stuff with transducers or using transducers in your stuff?
Can you explain the difference and how that operates versus the float?
Yes. Inside this float switch here, and this one's a mercury, there's a little glass tube with mercury and 2 prongs that stick down. So when the float switch is hanging down like this, the mercury's in the bottom of the glass tube. When it tips up, the mercury goes down and touches the 2 prongs and completes the circuit. Okay? This is basically the same thing, but it's just a mechanical ball inside with a little lever switch. So when you tip it up, you can hear the little ball come down and hit the switch and activate the switch. What a transducer is actually some type of a strain gauge relief that's built down into this little stainless steel head. And based on the pressure at the bottom of that wet well, you're going to see an increased pressure on this strain relief, which is going to send an electronic signal based on how much pressure there is here into the control panel. When you have a device like this, you have to have some type of a special device that can read that signal. So float switches can go basically into any type of panel that takes a switch. This you'd have to have some type of a controller or a PLC to be able to read that signal that's coming out of it. So.
Is the benefit to that it's more sensitive than floats?
There's benefits and drawbacks to both of them. One of the nice benefits of this is, yes, you can get more sensitivity of level. It's more easily settable. I can set the level from inside the panel that I want it to turn on and off because I'll have a device, I'll just punch in whatever my level is. This sits down at the bottom of the wet well. If you're having a lot of problems with grease, float switches will fill up with grease, and I've seen them so heavy that they won't even tip up in the water from grease. But this has its problems too. If you get something that would happen to hit the bottom of the strain gauge and mar the strain gauge, this device won't work. If you have a lot of sediment in your tank and this is sitting in the bottom of the tank, the sediment will stop this from working because it won't see the pressure change. So as a rule of thumb, I tell all my engineers, if you stick one of these in a panel, stick 2 of these to back it up. Because if this fails, that'll give you a high water alarm or your low level cutoff to stop your pump from running. So the other benefit is price. Float switch is $20. These usually are in the range of $800 if they go bad.
Well, that's set. 4 of those orange. Yes.
We see these most of the transducers are used in some type of an operation where they want to maintain a flow level. So if you have a treatment plant that is allowed to have 50,000 gallons a day and they get a water surge because of a rain event and they're going to get 100,000 gallons that day, you can actually have a pool outside of the plant that'll catch at a catch basin, and you can use this to feed a constant flow into your plant so you don't overrun your plant.
Could you go over the basics a little bit on the panel? Because a lot of these guys don't see panels a lot, so just kind of show them where everything is, or
okay.
On a simple one.
Let's do this one. This one's pretty big. We talked about, in this panel, notice we don't have any of the large black power blocks I showed. All of our blocks are these because the amperage rating is pretty low for this panel. So all of your field connections are on these terminal blocks. Okay, up here in the upper corner here, you'll see these are your circuit breakers, the 2-pole breakers for your pump, and you have a single pole breaker here for your control circuit stuff. I did not touch on base on this one. I talked about NEMA and IEC, but this is a definite purpose contactor. In pumps where you have the overload built into the pump, there's a possibility you'll see this definite purpose contactor. You'll see the large wires coming into the 2 terminals here. These are your power connection terminals. And it's kind of difficult to see, but down on the top here is your control circuit, that coil circuit that I showed you on there. So the 120 volts gets applied to this coil. That's a magnet inside there. It pulls the contacts down so it turns on your pump. This panel happens to be what we call our economy time dose. It has a different looking little timer that we've started using here. This is made by Siemens, and it has your off time and on time settable right here. And the reason we started using it is it's so versatile. It'll go from, I think it's 0.1 second range all the way up to like 10-hour range you can set on one of the dials. So
What would that fit on?
Excuse me?
What would that fit on?
What would this fit on? I believe this one is rated for 20 full load amps. So this contactor on 20 full load amps, you're probably looking at about a 1 horsepower, 115 volt pump. We're probably looking about 2 horse on a 230.
Cost?
Cost on something like this, what are we selling these for, Rush?
Probably around, column like I've heard $400, $500.
Okay, just ballpark.
Yeah. And this panel just happens to have in it too the sound alert and silence. So you're getting an audible, visual. You know, it's kind of designed around doing that time dose stuff for like a mountain system or something like that for the state requirements. You'll see here, for the state requirements, we have the elapsed time meter and a cycle counter built into one unit for you. So you can tell how many times the pump pulled on and how long it's run.
What's the piece of equipment cost to read?
It just shows you right here on the screen. The screen.
And
So
to
that's-
service those, what do you really realistically have to have in equipment to go out and service that?
To go out and service this, very, very minimal piece of equipment to service it.
Okay, that's what, it's not working properly. What kind of test equipment do you need?
I would say that you could troubleshoot this panel with just a basic multimeter.
Okay.
I work a lot of times with the people that call in and I help troubleshoot the panels. And most of the panels with the logic, if you understand the diagram and you can read the diagram, I can walk through and without a voltage meter tell you where things are not working. Because if I come out and the pump isn't working, I flip it into hand. If the pump pulls in, I know that the fuse is good and stuff like that, then I've probably got a problem with the float switch or somewhere else in the circuit. So most of the panels, if you use a little bit of common sense, you can flip a switch or something to eliminate where you think the problem is. Now if I flip that up into hand and the contactor doesn't pull in, it tells me it's probably going to be one of 2 devices. I've probably blown a fuse, or the coil for this contactor may be bad. So I check my fuse, and then if the fuse was good, I'd suspect the coil for the contactor was bad. In the bottom of this one, you'll see that we have installed cable grips. And what this is basically built for is to keep the sewer gases and stuff out of the inside of the panel. If you get sewer gases up inside the panel, it'll start to turn a lot of the copper stuff in here black, and you get some corrosion. You don't have very good working capabilities for the panel. I think that pretty much covers all the stuff that's in this panel. I also brought with me today.
I see that on the gate system.
The funny thing is, these panels do basically the same thing. This panel is just a little bit more powerful in what it can do because we actually have installed inside this one a little programmable controller that I've built a time dose program into. So it takes all the elapsed time and everything and stores it inside this unit right here, so you can see those elapsed times in this unit. It's real easy to set as far as the time settings. You push the left arrow key and it'll start scrolling through the times, but you're setting minutes and seconds and stuff that you actually recognize as opposed to percentage of a dial or something. Excuse me. This panel here is just, like I said, it's just a little bit more robust than the economy time go stuff that we do. Something like this, you're probably in the price range of $500 to $600 as opposed to the $400 for that one, but it gives you a little bit more working capabilities because of the device we have in here for the time dosing. And you see on the screen here, or on the subdoor here, because of this device, I can give you a time dose or a normal dose. You can go to a demand dose. So it's field selectable to go switch that to a demand dose if you want to do that. That's pretty much all I've got. Like I said, if anybody has any questions. Again, thank you for your time.
Thank you, Dave. Yeah, we appreciate that comment. Giving us that enlighten us. I think the schematic thing is something is beneficial for anybody that's trying to troubleshoot these things. For the service providers in the room, David mentioned about the requirements now requiring, we've always seen high water alarms, but we're seeing a lot more, well, elapsed time meters are required, or event counters are required in the panels now. And I have been to a handful of properties already where they were invaluable to know what kind of water folks are putting into the system. I wish everything could happen. Gravity systems, there's no easy way to do that. But the ones with pumps, man, they've saved our butts many a time to know what's going on with the system. Yeah.
Are we allowing just the water meter coming in if they have, city water?
Yes, that is still permissible, a water meter. Everybody understands, though, that there is some inherent flaw with that, because if they're watering the lawn, it didn't go to the system. But yeah, we can still use that if you're just using a simple high water alarm and you're on municipal water. And the service providers in the room, things to keep in mind is as you begin to inspect systems that are mounds or so forth, they're a little more complicated. They do have time dosing, and you do have to check distal head pressures and make sure that the whole thing's working properly. Probably not too many of you have seen them yet because these new houses aren't selling yet, but they will, and you will probably begin to see them. And you might want to get educated or defer to somebody who understands these types of things. A lot of the installers, probably most of the installers in this room at least have done some kind of a mound or something with some of the more complicated controls on it. So we appreciate them enlightening us a little there. Last thing I just want to say is be sure, if you haven't already, that you've received an index card. Has anybody not received an index card has come late? Okay. Make sure your name's on it, your company name, and any questions that you'd like to see us deal with. We'd appreciate that. Here in the beginning of December, you will receive your application for next year. You'll receive your certificate for today in the mail.
You turn your index.
And you'll also receive the final notice of the final CEUs that we'll be providing December 9th, I believe it is. December 9th, 8 to 10 a.m. Let's hope for bad weather and you won't waste any time in here. So December 9th, next meeting, you'll get a notice on that. The registration will come out here end of November, beginning of December, and the CEU that you've obtained today will go out also. Yeah.
I thought of something while they were talking about the permits. What do you know about the NPDES with the state?
Yes.
We're at the end of our 5-year
Yes.
cycle.
Yes.
I've also heard that if anybody from June on of this year was not going to receive a reapplication for the state permit.
Yes.
What do you know about that?
That's about what I've heard too, Jim. You pretty much summed it up. Yeah, so you're about the same place I am. They are renewing. My understanding is there's not going to be a lot of changes in the NPDES permit. There was a meeting here actually with Ohio EPA, and he basically reiterated what you just said. So far as the fees and the renewals, we understand that too. I don't remember the exact cutoff date, but they are trying to give some deference to people who have late in the 5-year process paid their money and done that.
Because I have people call me and want to know, we're getting close to the 5 years.
Yeah.
What's going to happen? And I hate to just tell them, I don't know.
Well, I have not heard the definitive. Now, the big question that's hanging out there is the fee.